if f and g are differentiable at x, then d dx of f of x times g of x, so a product. Now it says f of x times g prime of x plus g of x times f prime of x. So what does that really mean? Well, sometimes the way I say this is I will say this is the first, right? The first factor. And then it's times, and this is the derivative of the second factor. Derivative of the second. Then it goes plus, I can't write, plus second factor times derivative of the first factor. So you'll kind of hear me say this over and over again when we're doing product rule. So in the first example, this is a product. Now, if I had been doing this on day 3, I would just FOIL through and then take the derivative of each term. Today, I'm going to show this is why it says do in 2 different ways. The first one, f prime of x, I'm going to practice product rule. So product rule says first, so leave the first exactly as is, times the derivative of the second. So I'm going to do the derivative of the second factor, which is 3x squared, plus second, so the second factor just as it is, times derivative of the first. Derivative of the first is just 2x. So I could distribute 3x to the 4th plus 3x squared. Here, if I distributed, it's plus 2x to the 4th plus 6x, which is 5x to the 4th plus 3x squared plus 6x. That's my f prime of x. Now, someone else might say, well, I'm going to take f of x and I'm going to FOIL through. So I'm going to say f of x is x to the 5th plus 3x squared plus x cubed plus 3. Because I'm going to FOIL. Then they would take the first derivative, 5x to the 4th plus 6x plus 3x squared. Derivative of 3 is 0. So notice, so they could say, okay, that's my answer, which is the same exact thing as we have here. So 2 different ways of doing it. So when do we really want to use or kind of have to use product rule? Well, if I was doing the next one, I don't want to have to do x minus 2 cubed, then x minus 1 to the 4th, and then multiply all that together, because I'm probably going to make a mistake if I did that. So I would rather just take the derivative by doing product rule. So first times derivative of the second. Now derivative of the second, so derivative of this, the 4 goes in front, subtract 1, so it's 4x minus 1 to the 3rd, plus second, which is the x minus 1 to the 4th, times the derivative of the first, which is 3x minus 2 to the 2nd power, because again, subtract 1 off of the exponent. Okay. And sometimes what people will do, so I guess I'll say or, I mean, you could leave this certainly, but sometimes people will bring the coefficients out in front. So the 4, they would move to the front of the first term, and then the second term, they would move the 3. So either or, is fine. Okay. Next one, this is just a different way of writing it, d dv. So that means take the derivative of d with respect to v, which means in terms of v. So this is doing d dv of, this is v squared times, I'm going to write this 2v to the 1/2 plus 1. So again, I'm just going to write square root as to the 1/2. So when I do the derivative, it would be first times derivative of the second, which is v to the negative 1/2, right? If we have 2v to the 1/2, half of 2 is 1, subtract 1, that's negative 1/2. The plus 1, the derivative of that is 0, plus second, which is 2v to the 1/2 plus 1, times the derivative of the first, which is 2v. Then here we could, this is v to the 3/2, plus if we distribute here, this is 2 times 2, 4, v to the 1/2. This is v to the 1. When we're multiplying, we add exponents, so that's v to the 3/2 plus 2v. So this is a 1v to the 3/2 plus a 4v to the 3/2, which is a 5v to the 3/2 plus 2v. Next one, d dx of x squared e to the x. Well, we would go first times derivative of the second. Derivative of e to the x is e to the x, plus second times derivative of the first. So this could be your answer. Sometimes people will say, well, I could factor in e to the x out of both, and it would look like that. Doesn't really matter. You don't have to do that. F prime of x here, we would go first times derivative of the second, which would be 3x squared, plus second times derivative of the first. Now, derivative of the first, I would have to think of this as 2x to the negative 2 plus x to the 5th. So when I take the derivative, it's negative 4x to the negative 3rd plus 5x to the 4th. And, technically, you could just leave this, all of this, or you could distribute through. I'll just kind of say if you distribute through, you can try that yourself, but this is what you would get all kind of cleaned up. Okay, quotient rule. So they give you a derivative of a quotient. They say g of x times f prime of x minus f of x times g prime of x over g of x squared. Okay, so the way I remember this is I say low, d high. So what that means, low basically means the denominator, right? D high means the derivative of the numerator. Minus high, d low, so high times d low, all over low squared. So I'll often say low d high minus high d low over low squared to do derivative of a quotient. So here we have a quotient. To take its derivative, we are going to do low d high, derivative of the numerator, minus high, which is all of that, d low, derivative of the denominator, 2x, all over low squared. So notice I put brackets following that subtraction sign. Once you're going to have more than one thing following a subtraction sign, you want to use the parentheses. So if I foil through the top, distribute over the low squared. 2x cubed minus 2x cubed is 0. 3x squared minus 6x squared is a negative 3x squared. Negative 2x minus 8x is a negative 10x. And then we have that minus 3 over that denominator squared. So this is my answer. This one I would first write as d dx of 1 over e to the x. So derivative of e to the negative x, that could be written as 1 over e to the positive x, because it's like e to the x raised to the negative 1, which is then 1 over e to the x raised to the positive 1, which is 1 over e to the x. So now if I use quotient rule, I go low, d high. Derivative of 1 is 0, right? Derivative of any constant is 0. Minus high, which is 1, d low. Derivative of the denominator is e to the x. Derivative of e to the x is e to the x over low squared. So the first, that wipes out, that's 0. So we have minus e to the x over e to the 2x, right? Power to a power, you multiply. And then remember, when you have the same base, you could subtract exponents. So this is negative e to the negative x, right? 1 minus 2 is a negative 1x. Okay, so for example 5, f prime, we're going to find f prime of 1. First, we need to find f prime of x. So we're going to go low, d high. Now the numerator I'm going to want to think of as this. 1 over x is x to the negative 1. When I take the derivative 3 is 0. This is 1x to the negative 2. Power rule. Minus high, d low is 1 all over low squared. Now, I wouldn't even bother cleaning this up. I would just plug in. It's going to be easier if you just plug in 1. So 6 times 1 to any power is 1, minus 3 minus 1, which is 2, all over 6 squared, which is 36. So this is 4 over 36, or 1/9. Again, that could be representing the instantaneous velocity, the slope of the tangent line, the instantaneous rate of change. Okay, equation of the tangent line. This is the last one. F prime of x is, we would go low, d high, minus high, d low, all over low squared. Now, we have to write the equation of the tangent line at the point 3, 2. So I'm just going to plug 3 in. Again, I'm not going to bother cleaning this up, because if I make an algebraic mistake, then I'm in trouble. So we're going to just plug in 3 for x. All right, so we got 9 minus 4, which is 5 times 6. Minus here, we've got 4 times, or no, just kidding, 10. 3 squared, 9, plus 1 is 10 times 6. All over 5 squared, which is 25. So this is 30 minus 60 over 25, negative 30 over 25, or negative 6/5. That is the slope of my tangent line. So to write the equation of the tangent line, I would go y minus the y coordinate equals the m parenthesis x minus the x coordinate. So that is the equation of my tangent line. That is it for day 5.